Okay, today we will discuss about how to draw a velocity diagram for slider crank mechanism. Okay, here the problem which I have uploaded in the PPT, I have taken the same problem, and here the link OA link length they have given as OA as 500 millimeter, and EAB, which is connecting rod, which is 2000 millimeter, and crank is rotating at 180 rpm counterclockwise. So and also 60 degrees they have given. So first we have to construct the configuration diagram or a space diagram, and here first I'm drawing one horizontal line. Okay, I'm drawing one horizontal line here, which is the fixed link. Okay, which is a fixed link, and now I am choosing a scale of 1 centimeter. Okay, for configuration diagram scale I am choosing 1 centimeter is equal to 200 millimeter. Okay, so it will be OA will be at 500 by 200, so it is 2.5 centimeter. Okay, so before going to draw OA, actually it is they have given I'm marking this as O. Okay, from here I'm marking 60 degree. Okay, uh, okay, 60 degree, and now I'm drawing a line of 2.5 centimeter. Okay, 2.5 centimeter, and I am marking this as A. And now the crank AB, okay, the connecting rod AB, they have given like 2000 millimeter. Okay, so now 2000 divided by 200, it is 10 centimeter. So I am taking a compass, and I'm measuring 10 centimeter. The scale actually depends on you. Okay, you can choose any scale, and you should write. Okay, okay, so this is 10 centimeter. So from A I will draw an arc on this horizontal line. Okay, so this is our the slider B. Okay, so I can connect A and B. Okay, A and B here, and this is our the slider. Okay, and this point is G, and this is anyway hinge joint O, and this is 60 degree, and AE, they have given AE is 450 millimeter. Okay, so AE actually you can extend this line, okay, to get E here. So here so 450 by 200, so it is 2.25 centimeter. So you just extend this AE line. Okay, extend this AB line 2.25. Okay, so this is E point. Okay, we have finished the configuration diagram here, so we can construct a velocity diagram now. Okay, so before going to discuss draw the velocity diagram, how many fixed points we have to check, and here it is rotating with omega. Okay, n they have given 180 rpm counterclockwise. So now here how many fixed points here? A and G, two O and G, two fixed points. So I'm just marking O and G as one point. Okay, so because this and this every link, okay, this is a whole link is fixed. Okay, so now omega you can calculate, it is 2 pi n by 60 here. Okay, 2 pi n by 60 if you calculate, and then you can get 18.85 radian per second. Okay, so link OA. Okay, magnitude actually it is V is equal to, you can say V A relative to O. Okay, velocity of A relative to O is equal to R, that means OA into omega 18.85. so you will get 94.25 mm per second. Okay, so now to draw the magnitude and direction, actually here direction we know that it is perpendicular to OA. Okay, we have to draw a perpendicular to line starting from O here, and how much magnitude, actually here you will select a scale of 1 centimeter. Okay, 1 centimeter is equal to, I am choosing 1885 mm per second. Okay, so that you will get 94.25 divided by 1885. So you will get 5 centimeter. Okay, so this is 5 centimeter. Okay, so now we will draw a perpendicular line here. So place the scale on 1A on the link. Okay, and move this and draw one line. Okay, why I am drawing here? Because it is rotating in counterclockwise direction, and this will be 5 centimeter. Okay, this will be 5 centimeter, and mark this is A. Okay, this is A. And now what we will do, we know the direction here, OA direction is in this direction. Okay, and to locate B, okay, actually we know that the slider will move in like this horizontal direction. Okay, now the crank is rotating in counterclockwise, so it will move in this direction. Okay, towards left. Okay, so now you will draw a parallel line to this B here, the slider. Okay, you will draw a parallel line from G. Okay, you will draw a parallel line from G. Okay, on this line actually there exists B. Okay, there exists B. Okay, so now to locate okay, so I am drawing here, draw parallel line to B from G. Okay, to locate B actually we will draw again perpendicular line to AB, stop from A, because A is a known point. Okay, A is an, sorry, this is a small letter. Okay, so A is a known point, we will draw a perpendicular line from this. Okay, so place this and move this like this. Okay, so this is the perpendicular line. Okay, the intersection point will be B. Okay, intersection point will be B. Okay, so to know the directions, of these vectors, you write the equation. Okay, velocity of B relative to O is equal to, the velocity of B relative to O will be equal to velocity of B relative to A plus velocity of A relative to O. And also actually O and G are both fixed points, so you can say this is velocity of B relative to G. So in vector forms, actually the OB vector will be AB vector plus OA vector. So here what OA vector we know, okay, OA vector we know, OA plus AB. So this is the direction AB vector and this is the resultant. So these are the directions of these vectors. So you can make thick lines here. Okay, so the first question is velocity of the slider. Okay, velocity of slider. Okay, so what is the absolute velocity of the slider? Okay, what is the velocity? So take a compass and measure this OB. Okay, OB. Okay, and you just measure this. I am getting 5. Okay, so this is velocity of B relative to G, you can say, because G and O are fixed points. So I am getting 5 centimeter, but our scale is 1 centimeter is 1885. So you can say that this is also 9425 mm per second. Okay, so here the second question is the velocity of point E. Okay, the velocity of point E. That means the velocity of E relative to G, or otherwise the velocity of E relative to O. How much? Okay, so it's a absolute velocity of point E. So this is also a point on the link. So we know that EA divided by, okay, EA divided by AB is equal to EA divided by AB. So from this, EA is equal to AE by AB into AB. So AE is 450 divided by AB is 2000 into AB. Okay, AB you can you can measure here. AB how much? I'm getting 2.5. Okay, so this is 2.5 into 1885, because our scale is this one. Okay, so this is equal to so 450 into 2.5 into 1885 divided by 2000, 1060.3125 mm per second. So to locate E here, again we have to divide by our scale. So if you divide by this by our scale divided by 1885, you will get 0.56 centimeter. Okay, so EA will be 1060 by 1885. You will get 56 centimeter. Okay, so you just take a scale. Okay, this is a EA vector. Okay, EA vector, that means actually here it will be like it is upside. Okay, okay, so this is E point. Okay, so this is E point. Okay, so this is E point, and you connect with the fixed point OG. Okay, so VEO. Okay, VEO or OE vector. Okay, will be, you can take a scale and measure this. Five point 25. Okay, 5.25 into 1885. So 5.25 into, so 9896.25 mm per second. Okay, so another question here. Velocity of point F. Okay, velocity of point F. Okay, F is a point on connecting rod having least absolute velocity. Okay, so for this actually you can say that F will be on this link AB, okay, somewhere, and you have to calculate where is the point. Okay, point F. Okay, point F, and the velocity of F relative to fixed point will be a least possible velocity. Okay, so further to get that, actually here if you draw a perpendicular line from this, okay, the least distance, okay, it is the least distance. So now we will draw a perpendicular line to this. Okay, we will draw a perpendicular line to this AB. Okay, AB. Okay, why we are drawing perpendicular? Because it is the least possible distance. Okay, so this is the F point, and you can calculate OF. Okay, you can calculate OF. So I'm saying you can say OF. You have to draw perpendicular to AB. Okay, so OF will be, you can take a scale and you can measure it. So this is 4.8 into 1885. (9048 mm per second). Okay, the fourth question here, the angular velocity of AB. So omega AB is equal to V is equal to R omega. So V AB, okay, divided by, because AB is known, okay, and EAB here. So VAB, how much we measured, whether we calculated? No. Okay, so EAB you can measure. Yeah, EAB we have done here. Okay, so AB is 2.5 into 1885, okay, divided by 2000. Okay, 2.5 into 1885 divided by 2000, so 2.35 radian per second. And here the rotation, actually, if the crank, okay, so OA is a crank and it is rotating counterclockwise, so it will rotate in clockwise, so you can mark the clockwise here. So once if you finish this, actually the last one is the rubbing velocities. Okay, rubbing velocities, okay, at pin O. At pin O, you can calculate the radius of the pin at O. Okay, they have given the diameters here, so 80, okay, 80 by 2 the radius into omega of the crank, so because it is only connecting OA and okay, OA, so 18.85 you can calculate, and somewhat radian per second at pin A. Pin A is connecting link OA and link AB. Okay, so link OA is rotating counterclockwise and it is rotating anti-clockwise, so the diameter they have given 60, so 60 by 2 into 18.85 plus omega we have calculated 2.35, okay, at somewhat radian per second. At pin C, okay, pin B, the slider is not rotating, okay, it is just sliding, there is no angular velocity, right? So here the diameter of the pin is 100, so 100 by 2 into omega of the link AB, so it is 2.35 somewhat radian per second. Okay, so like this we will draw the velocity diagram for a slider crank